Let's close out this chapter by reaffirming some of the ideas. A short, cute chapter with really important physics to understand. And despite all the equations, the physics is fairly clear and straightforward. So just focus on that if you are nervous about the math. So here, just reaffirming the role of PVS fluxes in determining the zonally averaged tropical circulation. Just look at the steady state zonally average zonal winds in this black curve here, and the zonally averaged PVS fluxes for the maritime continent experiment from the shallow water monsoon, the shallow water model. You can see the clear correlation between the two, which clearly attests to what we just said, that the PVS fluxes and the dissipation in the tropics contribute to maintaining the zonal mean upper level circulation in the low latitudes. Okay, incredibly high correlation, even though it's a simple shallow water model. But if you look at the variations, this is the mean over certain time period. But if you look at the individual events of these bursts of Rossby wave activity, you can see there is a high variance in terms of these green curves. So this is showing the different time steps of the simulation. So when you average over time, you clearly see the correlation with the zonal winds between the zonal winds and the PVS fluxes is very high, even though we expect that this system full of breaking filaments and advected around in the easterlies and advected back to the north and so on will have high variance because they are recurrent events. This is what we had argued before, that since they are recurrent events in a band, you can do average over a certain time and get the good mean picture that gives you a sense of the impact of the PVS flux on the zonal mean zonal circulation in the deep tropics. Okay, so that's that story with the shallow water model. To close out, we can look at recursively breaking Rossby waves in a bit more detail. Going back to our kinematics, along the ray path we had written the relation for the zonal wave number in terms of the basic state with stretching with the meridional shear. We aren't going to talk about the vertical shear here, but we are only looking at the upper isentropes, so we'll ignore that. But we'll also look at the energy that gets accumulated when you have the basic state squishing or increasing the scale of the waves. It's easier to look at the flow. Let's say here is our westerly jet stream along XX, and then you take a cross section in the meridional direction. We can look at the kinematic effects on Rossby waves propagating through the exit zone, which is related to the tropical upper tropospheric trough and the westerly duct. To the north of the jet stream's axis, you have negative stretching and negative meridional shear. So maximum westerlies are here and weakening here, so you get du bar dy less than 0. And to the south of it you get again a negative stretching, but you get du bar dy greater than 0 because going in the y direction you're going from weaker westerlies to the strongest westerlies at the jet stream core. We can use our kinematics here to talk about what happens to the Rossby wave as the background state is changing at the exit region, which is the recurrent Rossby wave activity that we are talking about, that is inundating the low latitudes. So if you look at time t0, t1 and t2 as a very schematic, the energy accumulation is increasing because the zonal wave number is increasing. Waves are getting shorter, trapped and depositing energy. Meridional wave number is decreasing, so they are becoming longer scale. Whereas to the south of XX here, the meridional wave number is increasing, so the waves are becoming shorter and also depositing energy there. So the net phase velocity is southward here of the Rossby wave, and at further time t2 you still have southward phase velocity, but you have the same situation. You can see the impact of accumulating energy and creating these breaking Rossby waves that we saw in the potential vorticity substance and so on. So this is a nice way of bringing back our wave kinematics into this situation of what is happening at the jet stream axis. All right. So it's just kind of a schematic, but gives you a good sense of what the physics is. Okay. Let's see. The final idea to conclude is that we are looking at a latitude longitude space here. We are looking at poleward PVS flux getting into the jet. So the PVS isoplates are Q1, Q2 and Q3. So there is divergent circulation happening here. So this is at low latitudes, that's at high latitudes. You're going from east to west, and here you are having Rossby wave dynamics as the jet exit region, and you're going to have distortion of braking, distortion and braking happening recursively as we implied here. And that inundation into the westerly duct into the low latitudes happening here, and you can see that the braking essentially means dissipation of PVS, which is going to help maintain the zonal mean zonal circulation in the low latitudes. Okay, so this is a very clear indication of why you have recursive Rossby wave, reversible Rossby waves, as well as Rossby waves that get into this changing basic state with meridional shear, longitudinal stretching, and then lead to these recursive breaking Rossby wave activities and distortion of the PVS as they get into low latitudes. Okay, so this is the main story there. Schematic diagram of the interaction of the divergent and Rossby wave domains of the tropics and the extratropics. A heat source produces a divergent circulation transporting potential vorticity substance that we defined toward the poles. That's the source. In turn, enhanced PV gradient supports a westerly maximum, so that's the jet stream, in which Rossby waves emerge recursively. These propagate eastward in a Doppler sense. So remember the Rossby waves, westward phase propagation, westward group velocity, but you have strong westerly basic state, so you have a Doppler shift. These propagate eastward in a Doppler sense through the exit region of the jet, where distortion takes place due to shear and stretching deformation of the basic state. Thus, restored Rossby waves break recursively and flux of PVS toward the equator is created, thus completing the circuit and fulfilling the impermeability theorem requirement of potential vorticity substance balance. This view is valid, equally valid globally. So not many no simplifying assumptions were made. Heating is allowed, dissipation is allowed, and the basic state is realistic in this case. Okay, that's the nice story of the tropical extratropical synergy and completes the story of several chapters which we have built along the way.